Welcome to Part 9 of the CipherVibe Cloud Security Capabilities series. This episode explains vulnerability and exposure management, why it matters, how the capability works, which mistakes weaken it, and how to build it in a measurable way. Exposure management expands vulnerability management beyond severity scores to include reachability, exploitability, identity, data, business context, and attack paths. The program should answer which weaknesses are most likely to contribute to material harm and which action reduces the most risk. The key idea is that a security capability is more than a product feature or a collection of alerts. It combines people, process, technology, decision rights, evidence, and continuous improvement. We will examine its architecture, operating workflow, failure modes, defensive controls, implementation roadmap, and useful metrics. Coverage is not the same as effectiveness. A dashboard can show thousands of checks while the capability still fails because evidence is stale, ownership is missing, or remediation is never verified. The business outcome should be explicit. Teams need to know which loss scenarios the capability reduces, which systems are in scope, and which remaining risks require a conscious decision. To understand vulnerability and exposure management, start with its architecture and vocabulary. The capability should create a traceable chain from source evidence to a security decision and then to an accountable action. First, asset inventory and ownership determine whether scanner results can become accountable remediation work. Second, vulnerability evidence includes affected versions, fix availability, known exploitation, reachability, compensating controls, and runtime presence. Third, exposure context adds internet access, privilege, sensitive data, lateral movement, business criticality, and threat intelligence. Fourth, risk acceptance records why an exposure remains, who owns the decision, which compensating controls apply, and when review expires. These concepts need shared identity, timestamps, provenance, ownership, and access control. Every summarized risk should link back to its source evidence and disclose missing information. A sound architecture separates collection, normalization, analysis, policy, workflow, and presentation. Teams can then test freshness, identity resolution, policy results, owner routing, and closure independently. Design for degraded conditions. Providers impose rate limits, schemas change, credentials expire, and events arrive late. A professional capability reports uncertainty and health instead of presenting incomplete information as fact. Trust boundaries deserve equal attention. Identify where data crosses accounts, tenants, regions, vendors, privilege levels, and administrative domains, then apply authentication, authorization, validation, encryption, and audit controls at those boundaries. A useful operating model for vulnerability and exposure management follows a repeatable evidence lifecycle. First, continuously discover internal, cloud, container, application, external, and third-party assets. Second, normalize and duplicate findings while preserving scanner confidence, timestamps, and evidence. Third, prioritize using known exploitation, attack paths, reachability, asset value, privilege, and fix feasibility. Fourth, route work to system owners through existing engineering workflows and group fixes by root cause or deployment unit. Fifth, verify remediation with fresh evidence and track recurrence, reopened risk, and exception expiry. The workflow does not end when a ticket closes or an API returns success. Security closure requires fresh evidence showing that the risky condition is gone and does not immediately recur. Ownership should be established before urgent findings arrive using service catalogs, business applications, on-call schedules, and escalation paths. Prioritization should explain the influence of exploitation, reachability, privilege, data, business criticality, compensating controls, and confidence. Repeated findings should drive changes to secure templates, defaults, libraries, identity patterns, and architecture standards. Define escalation points for missing owners, disputed priority, failed changes, and evidence that suggests active compromise. Those conditions should move into incident or risk governance rather than remaining indefinitely in a routine queue. The fastest way to evaluate vulnerability and exposure management is to study how the capability can fail. First, CVSS-only prioritization overwhelms teams with severe but unreachable issues. Second, unauthenticated or stale scans produce incomplete evidence and false closure. Third, counting findings rewards asset deletion or suppression rather than durable risk reduction. Fourth, patch urgency without availability planning can create outages or unsafe emergency changes. Fifth, external attack surface discoveries may lack owners and remain exposed while teams debate responsibility. These failures share a pattern. A local measure looks successful while the full outcome is weak. A connector, scanner, or repair can report success while coverage, exploitability, or recurrence remains unresolved. Measure whether the program improves important coverage, shortens exposure time, removes attack paths, and prevents recurrence, not how many alerts it produces. Exceptions need a reason, owner, compensating controls, approval, and expiry. Automation should reflect confidence, reversibility, blast radius, and business impact. Test both through controlled failure exercises. Correlate weaknesses instead of reviewing them separately. A moderate configuration issue, broad identity grant, exposed service, and sensitive data store may combine into a severe path even when no individual alert looks critical. A dependable vulnerability and exposure management program uses defense in depth. No single scanner, policy, gateway, or agent should be expected to carry the entire outcome. First, define authoritative inventories, scanning coverage, credential health, freshness, and ownership expectations. Second, use exploited vulnerability intelligence, reachability, runtime evidence, and attack path context. Third, set service objectives by risk tier and provide governed exceptions with expiry and compensating controls. Fourth, coordinate patching with testing, maintenance windows, rollback, and emergency change processes. Fifth, invest in secure images, dependency upgrades, configuration templates, and other systemic fixes. Control design should include preventive, detective, responsive, and recovery layers. Together, they establish safe defaults, identify drift, govern containment, and restore service. Least privilege applies to connectors, agents, orchestration identities, data stores, and administrators. Scope, separate, monitor, rotate, and test their access. Every control needs an owner and test strategy. Validate it with representative assets, negative cases, simulated attacks, provider failures, and rollback exercises. Integrate controls with engineering through clear pull requests, owner routing, reusable fixes, documented standards, and fast feedback. Preserve an evidence trail from detection through decision, approval, change, and verification. That lineage supports investigations, audits, lessons learned, and fair performance measurement without forcing teams to reconstruct history from separate systems. A practical implementation roadmap for vulnerability and exposure management should build trust before scale. First, establish coverage and ownership for critical assets before optimizing scoring models. Second, prioritize known exploited vulnerabilities and internet-facing systems with meaningful business impact. Third, integrate cloud, application, container, identity, and external exposure evidence. Fourth, shift reporting from backlog size toward exposure age, risk reduction, and recurring root causes. Fifth, use attack simulation and incident history to validate whether prioritization reflects real paths. The roadmap is incremental because a focused production scope lets teams validate evidence, ownership, workflow, and control safety before scaling. Useful measures include critical asset coverage, known exploited exposure age, risk-weighted backlog, verified remediation rate, and recurring root cause rate. Give every metric a precise definition, data source, owner, and known limitation. Pair lagging indicators such as exposure age with leading indicators such as coverage, control health, exception expiry, and secure template adoption. Maturity means the organization can discover important risk, explain it, assign it, act safely, verify the result, and learn from recurrence. Review the roadmap quarterly. Changes in architecture, threat activity, regulation, business strategy, and provider services can alter both priorities and assumptions. Retire metrics and controls that no longer guide useful decisions. For more cybersecurity market intelligence, research, and educational briefings, visit CipherVibe.com. CipherVibe is operated by Cloudsectech LLC. This video is general education, not legal, compliance, financial, or incident response advice. Never access or test systems without explicit written authorization.